know it took us a while to answer this question. Where was it? The cathode and anode question, which was this one. So I know it took us a little bit longer than usual. That's why we didn't finish the whole past paper. So I thought it would be a good idea to continue on this past paper today in this lunch live session. It's almost lunch, like afternoon session. And then I'm going to go live again later tonight and do, I think, a bio paper because I know you guys wanted to do an HL bio paper. So if you're interested in continuing the past paper we started yesterday, please stay along. I forgot which one it was. Let me find out which one it was. It was the paper 2, November 2024 HL paper. Okay, so the most recent paper 2 for chemistry. Your paper 2 for chemistry should look something similar like this. We already started this, so if you're interested in watching the previous ones, I'll try to upload yesterday's live as soon as I can on online on YouTube, so you guys can watch the previous one. And I think a lot of you guys struggled with the cathode anode question. So if you need more help with redox, make sure you check that part out of the YouTube. And if you guys don't have any questions, I'm going to go ahead and get started. Hi, Drake. All right. Does that sound like a good plan today? So I'm going to be going live twice today. 1 hour today now to try to finish as much as we can of this past paper, and then maybe 1 hour this afternoon to do bio, because I know your exams are coming up and it's very stressful. But I'll try to limit them into 1 hour intervals rather than doing like a 2 hour live, so more people can join at a time and more people can interact, and we can do maybe both bio and chemistry in one day, which could be exciting. And just a little reminder for everyone, this is the November 2024 HL paper 2, so the most recent past paper. And if you're SL, this is an HL question. Thank you guys so much for the roses. This is an HL past paper, but I'll tell you if you're SL, which questions you should be able to answer before. And if I ever forget to tell you, just let me know and I can do it. Did you do GCSEs or MYP? I did MYP. All right, I'm going to go ahead and get started in a couple of minutes. Do you guys remember how our crash courses start this weekend? On tomorrow, actually, on Saturday, Sunday, and Monday. So if you're interested in joining the chemistry crash course live, make sure you go ahead and do that. I've inputted a discount code that you can use to get 10% off. So make sure you use that code. And make sure you sign up before anywhere tomorrow, 9:30 BST, so you can join us live. I'm going to go ahead and get started if you guys don't have any questions. If you have any questions, please stop me at any time. If you want me to re-answer something, please let me know. But don't forget, crash courses start tomorrow, so if you want to join the chemistry live, try to purchase as soon as possible. Okay, we're going to start off with this question. I'm going to give you guys a couple of seconds to try to answer it in the comments, and then I'm going to go ahead and answer it together. So let's have a look. It says, sulfur trioxide is an important compound in industry. Sulfur trioxide has more than one possible Lewis structure, electron structure. Sketch 2 Lewis electron dot structures for SO3, one of which obeys the octet rule and one of which does not. This is the November 24 paper 2 HL chemistry. Let me rewrite the discount code because some of you guys missed it. So make sure to use this discount code to buy the crash courses before we start tomorrow. I know a lot of you guys would rather join it live than watch the recordings. You could also just watch the recordings. It's based on preference. I also really like watching the recordings because then I can speed up the video and put on 2 times speed. So I've pinned the M25, and let me know what you're thinking about this one. So what does it mean that something obeys the octet rule? What does it mean that something doesn't obey the octet? You have to draw 2. So I'm going to give you guys a couple seconds to think about it. And the sulfur trioxide is, what is it, guys? And for this one, it's a bit of a harder question because what you have to do, you have to write the electron dot. Usually I really like drawing the dash electron configure, like the electron structure, but now we have to use the dot, electron dot, so you have to use X's and circles. So be careful. Is this HL or SL? This is an HL paper, but if you're SL, you should be able to solve this. Okay, I'm going to give you guys a couple seconds to think about it, but remember, when we're drawing Lewis structures, we're going to have to think about how many valence electrons. So while you guys are doing that, I'm just going to search up how many valence electrons are in sulfur, or just pull out the periodic table, because you do get one on your exam, which is nice. Can you imagine not getting a periodic table? Okay, so both sulfur and oxygen have 6 valence electrons. Okay, So if sulfur has 6 valence electrons and oxygen has 6 valence electrons, and there's 3 oxygen atoms, I know that 6 times 3 is going to give me 18, and then sulfur is going to be plus 16, which is just 6 times 4, which should give me 24. 24 divided by 2 is going to give me 12, so I know I need to draw 12 basically dashes, or 12 pairs of electrons. So I'm going to start off with sulfur and connect it to my oxygen. And the way I like doing is writing the dash one first because I'm most comfortable with that one. Then I'll move on to the cross and dot. Okay, so I have my 1, 2, 3 bonds, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we see that there's an issue here because sulfur is not fully happy. It's not satisfied. It's not fulfilled. It does not obey the octet rule because sulfur must have 4 bonds. So what ends up happening is that one of these oxygen molecules bonds with my sulfur to form a double bond. So if we draw this in the electron dot structure, remember you have to symbolize the sulfur, for example, as X, or the oxygen as circles, and that's what I'm going to do. So the sulfur shares electrons 1, 2 here with what? With our oxygen. So this is our oxygen. They share this pair, and then we have our dot, our dot, our dot, our dot, our dot, our dot. And then we have a double bond here, so it's both the sulfur and the oxygen sharing the electrons here. We have our oxygen, and of course we have to draw 4 more dots to represent 1 and 2. And then, again, we have the same exact thing here, which shows this. So when you see an X and dot mixing together, just remember that's a double bond. Okay, someone asked, do you record this? We do record this, and I put them on YouTube, but I'm having struggle putting them up on YouTube lately. It's like been cutting off my live recordings, but I'll try again, and hopefully it stays up this time. So, by when should I know all this? What do you mean by when should I know all this? This is year 1 content, if you're wondering. Thank you guys for all the roses. I really, really appreciate it. Does she share recordings of the Zoom meetings? So for the chemistry one, what we did for bio is we shared like sections of their recording because some of you guys like wanted a free trial, but it's very hard giving a free trial of a crash course because it's only 5 days. So we did share some of the live crash course. And yeah, but it's not much. It's like an hour. All right. Are you also doing IB? I am. I did the IB. What science is this? This is chemistry. Is this A level? No, it's IB. All right, I'm going to move on. Hopefully this made sense. Just let me know if this didn't make sense. I can go over it again. Now, something that does not obey the octet rule. Remember, the octet rule is basically saying that there's 4 bonds to each of our oxygen and sulfur. So something that does not obey it goes beyond the 4 bonds. So you can just simply draw one where, for example, sulfur has 5 bonds, and that's something that does not obey the octet rule. So sulfur is, remember, it's the X's. So here is a sample 1 where I show you sulfur not obeying. And what is the sample 1 where sulfur is not obeying is when it forms double bonds, 2 double bonds rather than 1. And we see here sulfur does not obey the octet rule because it has 5 sticks or 5 bonds to oxygen, and that's not very good for oxygen. So I think this is a pretty straightforward question. If you're struggling with this, I would really recommend you just do a bunch of practice questions. Are the X's double bonds? Good question. Please, next question. Okay, I'll move on to the next question. But the X's are the electrons coming from sulfur, and the dots are the electrons coming from the oxygen. Okay, next it says, state how chemists decide which Lewis electron dot structure is more stable. So how do they decide which one's more stable? There's a specific thing that you have to calculate. Does anyone remember what you have to calculate? Will this be posted up on YouTube? I'm going to try, but I don't know why it's failing. Sometimes it's not just, it's only posting the first 20 minutes on YouTube. Very good, Aiden. Aiden said the formal charge, exactly. And I like the state that questions because all you have to say is just name the thing, which is formal charge. Very good, guys. And the one closest to 0, perfect. Next it says predict the length of each S to O bond in PM. Use section 10 of the data booklet. So we're going to go ahead and open section 10 of the data booklet here. And it's just referencing like the length of a single bond, the length of a double bond. What about resonance? Because of course we have a double bond to oxygen like we've shown here, but we know this structure has resonance. So if it has resonance, it's going to be a length in between that of the single and the double bond. So here, what do I see? I see my sulfur to oxygen bond. Let's see if I can try to find it. So my sulfur to oxygen bond is going to be 161. But since it's resonance, we know that it's a little bit less than that, right? Does that make sense, everyone? We have to say that all the bonds are a little bit less because it exhibits resonance. So the length of S to O bond is going to be less than 161. Okay, does that make sense, everyone? Is this Chem SL? This is part of the SL syllabus, but this is an HL paper. Thank you guys for all the gifts. How do you know it's resonance? Because we have this double bond and oxygen, and this double bond basically can occupy this, or it can be here. It can be here. You can have the double bond be in each of those spots. So if the double bond can move around, it means that there's resonance. The code for the crash course went away, so I'm going to put it up again in the comments. Make sure to join us the crash course as soon as you can, because we do start tomorrow. If you're really interested in joining the crash course and learning, please do. Okay, so just why atmospheric SO3 is an environmental concern, and this is a really common question to show up on both multiple choice and paper 2, because IB love every environmentally climate change related stuff. Very good. Someone put the correct answer. I'm going to give you guys a couple of seconds. Are bond lengths still in the curriculum? Yes, they are. Causes acid rain. Very good, guys. So we know that it reacts with water, so it reacts with rain to form acid rain. And that's all you have to say. Can you post yesterday's recording? Yes, I'll try. I'm currently having a bit of struggle, but I'll try again today. It says, state the name of the post-combustion method used to lower the quantity of SO3 released to the atmosphere. So what can you do to remove the quantity of SO3 from the atmosphere? Can you zoom out, please? Of course. I don't know why the crash course discount code keeps going out. So if you're thinking about purchasing the crash course, make sure you use the discount code. I keep pinning it, but then it goes away. All right, guys, how are you feeling about this? Is this on the new course? Yes, acid rain is on the new course. What paper is this? This is the November paper 2 HL chemistry paper. So the most recent past paper. All right, if anyone in the chat actually can just write M2510 in all caps, maybe if I pin your comment, it's gonna last longer. But what are we thinking? What's something that, it's just a mechanism that removes SO3. So because SO3 forms acid rain, can you guys guess what we're gonna have to put in to our acid rain? If it's acid, what can I put? Very good, flue gas thing, exactly good. But since it's acid, I know I'm gonna have to add a base, something to balance out the pH, okay? So you can't put NaOH because that's really, really strong. But someone did say calcium carbonate, which is good. You can add that. You can do alkaline scrubbing. And just like someone said in the chat, the flue gas desulfurization to remove all the sulfur. Very good, guys. If you're thinking of any of these, if you thought of any of these, good job. Yeah, exactly. You got it right. Okay. This one says SO3 is made using the contact process. So here it is. Sketch a potential energy for the profile for this reaction and the axis provided. I think this is a really nice question to get on your exam. So the potential of energy, just basically the enthalpy level diagrams. So if it's endothermic or exothermic. If the delta H is negative, is this exo or endo? Tell me, do some active recall. So I'm going to go live right now for 1 hour to try to finish this. And then I'm going to go live again tonight to remind everyone to buy the crash courses, because the crash courses do start tomorrow. And if you want to join live, very good, guys, exothermic. So I'm going to go live again tonight. And if you join early, you can vote if you want to do a bio or chemistry paper. Okay, if it's exo, are the products more do they have more energy, or is it the reactants? What are we thinking? Is this for A levels? No, it's IB. How much is the course? The course depends on if you're HL or SL. Yay! Gonna be good job, guys. So the reactants are gonna have more energy. So I start off with lots of energy in the reactants, and then I go like this. Oh, that's really ugly. But it's something like this. I'm going to draw that a bit better. And I have to include the activation energy. So which part is going to be the activation energy? Reactants have higher than the products. Nice, guys. This is IB. This is not GCSEs. So what's going to be the activation energy? The activation energy is the bump. Do we offer discounts? We do. The discount code keeps going away. Here is the discount code, guys. To join, you get 10% off. From the reactants to the peak. Exactly. It's just a bump you have to overcome. And so this is our activation energy. Nice. Let me force you guys to do some active recall to see if you guys are properly studying well. What's going to be this? What is the blue that I've mentioned? Someone said, isn't it a straight line? What do you mean, isn't it a straight line? Oh, yeah, you booked the chemistry crash course. Okay, that's nice. I'll see you tomorrow then. Delta H. Exactly, guys. We don't have to mention this, but just some active recall to help you practice. So what you have to do to get the mark, you have to label this correctly. You have to label the activation energy, and you have to just write reaction progress on this side, on the x-axis, and this is just the potential energy. So the mark you're looking for is this. I'm going to just put it in a different color so you can see this, what we drew in purple, and this, and that should all add up to 3 marks. Okay, so the x and the y are 1 mark, the activation energy is 1 mark, and then the purple is 1 mark. The discount is 10% off, so please use the discount code. Keeps going away, but I'll keep putting it. Is a 5 or more guaranteed if you join the crash course? Most of our students, I would say, I think it's 80%, I don't remember the statistic, but 80 to 90% score between a 6 and a 7. I think it might be 90, but I'll check at the end to let you know so I'm not spewing any wrong facts. But I think 90% of our students get between a range of a 6 and a 7. And we had a student who messaged us who went from a 4 to a 7, and we're very, very proud of that student. And they just messaged us recently about how they got into all their dream unis, which is very exciting. So if you do end up joining the crash course and you want to share your success, that's really, really inspiring for other students. Please go ahead and send us messages and DMs, and we'll be happy to post them on our stories. The crash course tomorrow will start at 9:30 BST AM. Okay, so explain why increasing the temperature increases the rate of reaction. What do you have to mention when you're talking about temperature and rate of reaction? Good. I'm not sure if Dot is your actual name, but Dot's been slaying in the comments right now. She's been saying everything correctly. So she mentioned both the kinetic energy, and then she mentioned that how, therefore, more molecules have energy higher than the activation energy. Good. So one thing you must mention, because there's 2 marks, remember, so you have to mention 2 things. The first thing is that you have more collisions, okay, with molecules that have energy higher than activation energy. That's 1 mark. The second mark is just say the frequency of successful collisions increases. Okay? So you talk about the frequency of successful collision, and then you talk about how more molecules have energy higher than the activation energy. Okay, let's have a look at vanadium pentoxide. It is used as a catalyst. Explain how the catalyst increases the rate of reaction. What are you guys thinking? So again, it's 2 marks. So try to, when you write your answer, try to think of 2 things that you can mention. Can you zoom out, please? Of course I can. Sorry. Someone asked for a 20% discount. I can ask the tech team to provide you guys with a discount code if you guys would like. If more people request it, I can. Lowers the activation energy. Very good, guys. So one of the things you can say is that it lowers the activation energy. And how does it lower the activation energy, guys? How can I get that second mark? So this is mark 1. And how can I get that second mark is by saying how that happens. Can anyone tell me? Ooh, someone also requested another 20%. Creates a new pathway. Perfect. Another pathway to produce the product. Exactly. So you can say alternative. So by creating an alternative pathway. And that's the first mark, and that's the second mark. And then the thing about increasing temperature and how that affects the rate of reaction and the activation energy, this is always going to be what you have to write in the mark scheme, which is very nice. So if you remember those things, then it's much easier and much faster in your exam because you can write them much faster. Okay, let me request a 20% discount code. See if I can give it to you guys, especially for this live. Just messaging our team. 20% discount code. Maybe 15% even. Okay, all right. So these questions are quite easy. Our exams usually like this. Good question. So I think this is just a really easy question to get. I mean, yesterday we did a bunch of other questions that were really hard, and that's why we weren't able to finish the past paper. So it depends. Usually your paper one's really easy, so then your paper two is going to be really hard, or your paper two is going to be really easy, so your paper one's going to be really hard. And I think for this year, the paper one was really hard, so the paper two was not as easy. Sorry, it was easier. Okay, let's have a look at this. It says, during the reaction, this V2O5 changes to V2O5. Identify the oxidation state of vanadium in each compound. What are you guys thinking? So oxidation state. What do we have to give priority to? Is it going to be the vanadium or the oxygen? Do you guys remember? Share the code, guys. I will. I'm just working on, they're working on creating a new code. This is the November HL Chemistry paper 2. So the most recent past paper. Good. Exactly. If you said oxygen, you give priority to the oxygen. Good job, guys. So here you have -2, because oxygen is always -2. And this -2, you have 5 of those, so you have an overall charge of -10. So that means your vanadium has to be +10. But since you have 2 vanadiums, that means each of the vanadiums is going to be what, guys? +5. So for the first one is +5, and we do the exact same thing here. So this is -2, it's going to become -8, and therefore this has to be +8, but since there's 2 vanadiums, each of them is +4. Did that make sense, everyone? Please let me know in the chat if it did. Exactly, good. Good, Hanya, +4 and +5. Can you find this past paper online? You can, I found this online. If you search up the past paper, or if anyone can drop any resources to share, guys. Yes, if you paid for the crash course, couldn't you join the crash course later on and watch the recordings? Of course you can. We just know a lot of people are like joining it live. That's why I'm informing you guys. Why do you consider oxygen? You always consider oxygen and the hydrogen as your main priority. And then of course you also consider metals, but like alkali metals. Is this for A level? No, this is for IB. So someone said IB docs for all free past papers, brilliant learning for past papers, so make sure you guys check those out. Okay, let's move on to the next one. It says, state the equilibrium constant expression for the production of 1 mole of SO3. What's the equilibrium constant expression, guys? What is it? Is it reactants over products or products over reactants? This is November, so there's only one time zone. The November exam is only one. Good, someone put this. Good job, guys. I don't know what to call you guys to congratulate you for getting the answers correct, because your usernames are one letter, but good job, question mark, and P, and G, Lillian, good, and Hanya, good job. So it is products over the reactants. So it's pretty straightforward. But what do you have to add? Is it only the products over reactants, or what is an important thing you have to do? You have to apply the what? The ratios. What are the ratios? How do I find the ratios, guys? What do I look for? The coefficients are the powers, exactly. So the only one that has a coefficient in this case that's not 1 is the 1/2 of the oxygen. So I can just say to the power of 1/2 oxygen. And that's all you need to do to get the mark. I think this is a really good one to get. This is the 2024 November paper. Oh, thank you guys for 11K likes. Yesterday we tried doing, tried hitting 30K. We did not reach that goal, but maybe today we can. So thank you guys so much. And if you're sending any gifts, thank you. Okay, let's do this one. It says calculate the entropy change in delta S in kilojoule per mole, in joule per Kelvin per mole for the production of 1 mole of SO3. Use the absolute entropy values in the table. So when I'm thinking about entropy values, is this HL? It is HL. This is IB. So when I'm doing entropy, what is it, guys? You know how to calculate it? Let me know. Products minus reactants, good. Is anyone objecting products minus reactants? Are you taking this exam this May? No, I've already taken my exam, and I do lives now, and I joined Easy 7 to take part of the crash courses, so I can teach other people as well. Okay, So no one's objecting to product minus reactants, which is really good, guys. So the product is SO3. So I just take the value of SO3, which is 256.8, and I subtract that from my reactants. Now, what do you have to be careful of? You have to be careful that you multiply the ratio of the coefficients with the numbers. So in here, because it's 1/2 O2, I have to make sure to multiply by 1/2 O2. So 1/2 25.2 plus 2482. I think this is also a pretty straightforward question. All right, so how you just put this on your calculator and you should get roughly, let's see, what should you get? Times 205.2 plus 248.2. If anyone's faster than me, please help me out. 256.8. So you should get negative 94. What's the units? Joules, Kelvin, negative 1 mole. So if you got this, good job, guys. All right, now this, if my entropy is negative, does this correspond or is this accurately seen based on the question? So always when you get these entropy questions and these entropy calculation questions, make sure that you double check with the equation. Does what I found that the entropy is negative, does that correspond with the equation they've given me? So for this one, just by looking at the equation, can any HL student tell me if this increases or decreases in entropy? Do you have a limited amount of comments? You do not. You can comment as many times as you want in the crash course. Is this HL? I saw this HL. Exactly, because there's less moles of gas in the product, so the entropy decreases. Very good job, guys. So you know by looking at this equation that this should be a negative entropy value. So let's say you're in your exam and you don't know how to double check your answer because sometimes it's really hard. As long as you get a negative value, you're on the right track. Okay? All right. Good job, guys. So next says outline with reference to the equation why the sign for the entropy change. Oh, we already answered that question together. But it's good that we did that because sometimes they don't ask you to do that, so you might get the questions wrong. But just like you said, because there's fewer moles of gas on product side, entropy decreases. Okay, and that's all you have to say. Yes, this is an HL question. So calculate the value of Gibbs free energy delta G of the reaction in kilojoule at 773 Kelvin using section 1 of the data booklet, and it gives you the delta H. And we've already obtained the value for delta S, so we don't have to worry about this. But can anyone tell me, did we subtract products minus reactants because it's enthalpy of formation? No, we did because it's entropy. And in entropy, you always do products minus reactants. You're correct that if it's formation, you also do products minus reactants. Good job, but in this case, it was just because it was entropy. Ooh, the discount code went away, but if you guys are interested in the discount code to get 10% off the crash courses, I commented it again because we do start our crash courses tomorrow. So if you're interested in joining the crash course live, this is today's one of the last opportunities to join it fully live from the beginning. Of course, if you just want HL content, if you want to purchase it to just watch the recordings, you still have up until the last day of your exam. One year we had a student buy the crash course exactly 5 days before their exam, and they watched the recordings on 2x speed for the 5 days. It's at 9:30 BST. Okay, so how do we calculate the delta G, guys? What's the temperature for this question? Good question. It's 773. What is the delta G equation? The delta G equation, it's in your data book, so you don't have to really worry about it, but it's delta H minus T delta S. And it's telling me to find it in kilojoule per mole. So I'm going to enter my delta H values, which is negative 98.5, minus, does my temperature have to be in, someone said this is, the crash course is too early for them. So the crash course is not live. It is live. It is live. So you can join now live, but we do the live session, like the live 5 days crash course, once in an exam period. And so chemistry starts tomorrow, so make sure you want to join before tomorrow. This is HL Kelvin, exactly. Good job, guys. So 773. And then the entropy value we found to be negative 94, right? Negative 94 joules. What do you have to do before I can proceed to find delta H, guys? Tell me what's wrong with my equation right now. There's something missing. Which question is this? This is question 4. And it's the same past paper we were doing yesterday, Kavya. So this was the 2024 November one. Can you zoom out? Of course. Exactly. One is in kilojoules, one is in joules. Perfect. So what do you have to do to your negative 94? You have to divide by 1000. So be very careful. This is a common mistake that you can make. All right. Good. So now I'm just going to go ahead and calculate that. If anyone's faster than me on the calculator, please help me out. If not, I can just do it here. Just give me a second. Okay, what did you guys get? Where's the 94 from? That's the entropy value we found previously. I got negative 25.8 kilojoules. Did you guys also get that? Hopefully you did. Someone keeps asking to explain the oxidation of alcohols. I can. These are more past paper sessions. So if you want content-wise, I would really recommend you join the crash course because we cover all the content. And it's just in 5 days. This is chemistry. Because I think in the lives we'll be focusing on doing more practice questions. Good, Yasmin. Exactly, that's the unit. Perfect. Let's do the next one. It says calculate the value of equilibrium constant for the formation of SO3 at 773 Kelvin using section 1 to up the data booklet. If you don't obtain the answer for here, use this value, although this is not the correct answer. So it's telling you if you did not obtain a delta G value, you can just use what they've given you here. Okay, how would you go about doing this, guys? What equation do you have to do to find the equilibrium constant? Where will the crash course be? So you can join our crash course hub from our website and you get the resources and all the recordings on there. And once you join the crash course hub, there's going to be like day 1 and it's going to tell you the Zoom link. And so you press on the Zoom link at the time and you register with your name and like if you're chemistry, HL or SL, and then you enter the course and then of course you have access to the chat, you have access to the tutor, you can have access to the specific all little things in the Zoom. Good. Someone said the Arrhenius equation. Perfect, guys. So here I'm just going to look at my data booklet. The one that connects the, this is the Arrhenius equation, by the way. So careful. We need to have something for the delta G. So I'm going to be using R times T times K. K is the equilibrium constant. T is temperature in Kelvin. What is K? What is R, guys? Can anyone tell me? What is R? The gas constant. Perfect. So what do you have to do? You have to take your delta G, which we found to be negative 5.8. And of course, what do you have to do? You have to make sure that it's in joules. Okay. And that's your delta G. And then we're going to be multiplying it by the gas constant, which is negative 8.31. And then you have your temperature, which is 773 in Kelvin. And then you have your L and K. Oh yeah, sorry, I can zoom out. Just like this. Okay? And then you solve for your L and K. So your L and K is going to be equal to negative 25.8 times 10 to the 3 divided by negative 8.31 divided by 773. And then that should give you roughly 4.016. And then you take the ln of that, so e to the power of 4.0, so e to the power of 4.016 should be equal to k. And that should give you k is equal to 55.5. This makes sense, everyone. How did you feel about this question? So while calculating delta G, we use kelvins. Exactly. So actually, the only case in IB chemistry where you don't use Kelvin is when it's the change in temperature. So when any equation shows the change in temperature, you don't have to worry about converting it into Celsius and Kelvin. You just keep it as Celsius. But otherwise, in all the other cases, you always use Kelvin. All right? Did that make sense, everyone? Please let me know. Okay, I'm going to move on. So someone is asking about why the temperature impacts. The temperature impacts it because these laws only work in terms of Kelvin. How do I know from the question to use the equation? Because you're trying to find the equilibrium constant, which is K, and they're telling you to use the delta G value that you found. So you just look at your data book and you see which equation connects the K constant and the delta G, and therefore you know you have to use this one. Okay, I'm going to move on to the next question. Have like half an hour left, and I want to try to finish this so I don't spend too much time on this past paper because I know you guys want to do other past papers as well. I'm going to insert the code one more time because it keeps going away. But remember to use this code if you want to get 10% off in the courses. Okay, the next question says a flask containing 0.12 mole of SO2, 0.05 O2, and 0.15 mole of SO3 at 773. Deduce whether the system is in equilibrium. In which direction will it proceed spontaneously if not in equilibrium? How would you guys think about doing this? Is this an American exam? I think no, IB is European. Of course, I can resend the discount code. I don't know why it doesn't let me pin it or like save it. If anyone can write M2510 all caps so I can pin it, please, that would be very helpful. Okay, you have no idea how to solve this, no worries. So what did we do in the previous one? I mean, Kavya joined late, so I understand if you don't know how to solve this one. But what did we do? We wrote the equilibrium constant expression. Thank you guys for commenting it. Okay, we wrote the equilibrium constant expression, right? And they've given us the concentration. So all we have to do to find out if the system is an equilibrium constant is that we just substitute the concentration values in our Kc equation. So our Kc equation, remember, we just said is products over reactants and making sure we use the coefficients as powers. So our Kc is SO3 over SO2 over O2 to the 1/2. SO3, they told us, is 0.150. SO2 is 0.120. And then O is 0.05 to the power of 1/2. Okay, so once we've written this out, we're just going to calculate this Kc value, when these concentrations are this. And I'm going to go ahead and you should get roughly around 5.6. And if I get a Kc value of 5.6, and I know the equilibrium constant is at 55.5, can you guys tell me if this reaction is going to proceed to the product or the reactant side? So it's definitely not at equilibrium. So not at equilibrium. It's not at, because the values should be equal the same if it was at equilibrium. So y to the power of 1/2? Very good question. Because remember, when you're writing your Kc value, you have to take into account the molar ratios. And because this is 1/2 to the oxygen, your coefficient always becomes your power. Okay? So it's not at equilibrium. And where is this reaction going to proceed? Is it going to proceed to the product or my reactants? I'm going to rewrite the equation here. And I want you to keep in mind the Kc constant. Reactants, products. What is the Kc? Good question. The Kc is 55.5. This is the one we found. So if my Kc value is too low, I need to increase my Kc value. So I'm going to need to shift my reactant to the right. So I produce more product. So if you said shift to the products, good job, guys. It favors the product. It favors the forward reaction because I'm trying to increase my numerator. Because I know in fractions in general, if I have like a higher number in the numerator in comparison to a higher number in the denominator, that the higher number in the numerator means my number is much larger. And since I'm trying to reach this 55, I need to increase the number, so I need to increase the numerator. So this is why I increase my SO3, and my SO3 is in my product side, so I shift towards the forward reaction, I shift towards the product side. All right, does that make sense, everyone? Someone's asking, shouldn't you divide the concentration of each of the volume and then do the Kc, then do the Q and C? No. You should not. You should leave it in concentration. I can, of course. I can explain again. So, in your equilibrium, your Kc value is 55.5. This is the ideal Kc to reach equilibrium. It's telling you at this point, when I have these concentrations, so these concentrations here, my Kc value is 5.6. So it's way too low. Okay, so what do I need to do? I need to increase my Kc value. Okay, how do I do that? By increasing my numerator. Okay, because when you increase the numerator, your overall number increases. So I need to shift my reactants so I have a higher concentration of my products. So I'm going to shift towards the right. I'm going to shift towards the forward reaction to produce more of this product so that the concentration here is higher, so that my Kc value is much higher here. And therefore, you can have a higher Kc value, and therefore you can reach equilibrium much faster. Why is that the equilibrium? Because we calculated it. In the previous question, they've asked us to find the equilibrium. Remember, they said find the equilibrium constant. Does that make sense, everyone? Or would you like me to re-explain again? It does? Good. Yay! All right. If that made sense, very good job, guys. I'm going to move on to the next question. Can't you just say it's Kc is bigger than 1? No. You can't, because they're both the values bigger than 1. Your Q value and your Kc value is 1, bigger than 1. What do you mean? Can you rephrase that? Maybe I'm misunderstanding. Yeah, but this is... All right, I'm going to move on to the next one. But if you want to rephrase it, I can answer. And we're at 13K likes. Thank you guys for all the gifts and the likes. We're going to move on to this question. Let's see how much of this past paper we still have. Oh, bomba. Oh, okay, wait, this is old syllabus, so we don't have to worry about this. All right, let's try to speed run this, okay? So we can try to finish this past paper. If we can't, that's okay. I'm going to go live again today. Also later tonight, because we're celebrating the fact that the crash course is starting tomorrow. So if you really want to join the Chem live crash course, please do. Okay, we're going to go ahead and do question 5. We're doing very well. I know it's a lot of content, but paper 2s are very chunky. It says organic acids are weak acids. 20 centimeter of a sample of a weak monoprotic with a concentration of 0.15 mole decimeter was titrated with a solution of sodium hydroxide. Something that is weak was reacted with a strong base, a weak acid with a strong base, and giving the pH curve below. Determine the concentration in mole decimeter of NaOH used in this titration. So I started off with my weak acid, and in this titration, I dropped my base into my conical flask, into this weak acid, and at one point, this reaction finished this titration. How do I find the concentration? So here's telling me the volume, so I have to actually do a couple of steps before I reach the concentration. With the equivalence point, good. And what is the equivalence point? When I've reached a pH of 7, right? So I know it's going to be 18 centimeters cubed of NaOH. I have to be very careful that must convert it to decimeters, so 18 divided by 1,000. That's my volume. To find the concentration, I know it's moles equals concentration times volume. So moles divided by volume will give me concentration. So I have my moles, which should be given to me here. Where's my moles? How do I find my moles, guys? If they've given me the concentration and volume of the weak acid, how do I find the moles? How do you deduce the equivalence points? You just look at the pH 7 and where that intersects with the graph. Okay, because at pH 7 it's neutral. Use the given. Yes, good job. Use the given what? Because it's a monoprotic acid, we know that the ratio is 1 to 1. Always with this ratio that's 1 to 1, you can just say, okay, they have the same amount of moles. So I'm going to use the moles of the acid and equate that to the moles of the base just because it's monoprotic. And therefore I have 20 divided by 1,000 times the concentration, which is 0.15, and that gives me the mole value. So what moles is that going to be? That's going to be 0.02 times 0.15. I'm going to go ahead and just do that on my calculator really quickly. And that should give you 0.03 moles. And since it's monoprotic, we know that the ratio is 1 to 1. So I can just say that this is also 0.03. So to find the concentration, I need to do the moles divided by the volume. The moles, remember, we found to be 0.003 divided by 18 divided by 1000, which should give me 0.018. So 0.003 divided by 0.018 would give you roughly 0.167 mole decimeter cubed. Does this make sense, everyone? Can you explain how you find the moles? Okay, I can, of course. So, yes, why 20 divided by 1000? Because everything must be in decimeter cubed. Good question. Okay, how do I know that the moles? Okay, so monoprotic means that the acid only has one H. And I know if something is diprotic, it has two H's. So H2SO4 is a diprotic acid. HCl is a monoprotic acid, so it has one H. And if something is monoprotic, remember it's one H. And I know when I react an acid and a base, so for example, HCl and NaOH, if it's monoprotic, that means the ratio of hydrogens and hydroxide ion is equal. So when I form my salt and my water like this, okay, everything is in a 1-to-1 ratio because they're both monoprotic. But if you react a diprotic acid with NaOH, for example, which has one hydroxide ion, so like this, you form Na2SO4 plus H2O, and that's when your molar ratio changes. When you balance it out, your molar ratio changes. Sorry guys, I was zoomed in. But your molar ratio changes. So I know that when the IB is telling me it's monoprotic and it's reacting with NaOH, it's a 1-to-1 ratio. So how did I find the moles? I assumed that the moles of the acid is directly equal to the moles of the base because it was monoprotic. Now this is what you would get if it said diprotic. So you'd have to make sure that the moles of the acid, you multiply that by 2 to get the moles of the sodium hydroxide. But monoprotic means that they have a 1-to-1 ratio. Does that make sense, everyone? Please let me know. Someone said, significant figures are important. If you just put 18, it's wrong. I did this exercise. Good. So you do need to take into account significant figures, but at this point, you don't need to worry about the 18. Like, you would not get the marks off. I don't know who marked you off for that, but you should not get the mark off. Significant figures only matters with the final one. So only the final thing must be in 3 significant figures. It doesn't matter here because exactly. So it's monoprotic. The moles of the base is equal to the moles of the acid is equal to the moles of the base, exactly, because they both have one hydroxide ion. Now it's a bit different if you have, for example, Mg OH2. That's different because you have two hydroxide ions. And so when you're reacting it with H2SO4, which is also monoprotic, since they're both two hydrogens and two hydroxide ions, it's 1-to-1 ratio. So be very careful. If this doesn't make sense, everyone, I would really recommend you join the crash course. Because this is a really important part about acids and bases that you should know, and it's really commonly brought up. Or if you don't want to join the crash courses, make sure you review the monoprotic. Why do you do 18 divided by 1000? Because it must be in decimeters cubed. If I leave it as 18, it's going to be only in centimeters. Okay? Good. So I first calculate the moles from the sentence and then use the value from the equivalence point. Very good. Diprotic means that there's two hydrogens. So protic means it's like a proton donor. We know an acid is a proton donor. Diprotic means it can donate two. Someone lost the discount code. I tried to pin it, but the discount code is M25. Yay. Okay, hopefully that makes sense, everyone. I'm going to move on to the next one for the sake of time, but it says determine the pKa of the weak acid using the graph. So how from the graph can you determine the pKa? Someone said, hey, as a 2023, 24 student, this is kind of triggering. Yes, someone said, so you always use the equivalent point values? You do, because you're trying to find when this equation is neutralized. That's how much base you know you need to add. Because at the point of neutralization is how you know the volume of NaOH you need. So in this case, you have to find the equivalence point, which is when the pH is 7. Okay? And, or like when the graph basically starts becoming straight like this. So it would have to be 18. Half the equivalence point. Very good. So our equivalence point in this case is what, guys? I actually realized I did a tiny mistake. But the equivalence point here, guys, I'm so sorry, but if you have a weak acid, and a strong base, that means you have something that has a like a pH between 3 and, let's say, 7. And then this is a pH between like 11 to 14, right? So we know that the equivalence point is going to be roughly not starting low, just like they started here. And the equivalence point is going to be very, very high. So I said the pH is 7. It is supposed to be 7 if they're both strong and acids and strong base. But in this case, because you have a stronger base than you do have an acid, it's going to be roughly closer to the stronger base. So if you draw your graph and just draw half that line here, half the straight line, you can try to find out the equivalence point. Okay? So based on that information, how do you know the acid is weak? They told you. They tell you in the question. So it says it's a weak monoprotic acid. What are you guys thinking? So I would say that it's exactly like halfway. So somewhere around here, that's halfway between this line, that you can try to find the equivalence point. Remember, makes sense? Okay, good. So remember that it's going to be roughly around here. It doesn't change your pH, it doesn't matter, because the volume of NaOH, because the volume is the same throughout this whole line. So exactly good. The equivalence point is between like 8.8 and 9. Good job, guys, because this is a strong base. Sorry about that little mistake. And so the half the equivalence point would just be half of this, which is like 4.6, I'm gonna say. You do get a range where you can like put an answer, and it would still be good. So yeah, between 8 and 9. So the equivalence point will be 4.6. Sorry, half the equivalence point. So the pKa, which is half the equivalence point, is going to be 4.6. Does that make sense, everyone? Okay. I'm going to do this last question, and then I'm going to end the live. But don't worry, guys, I'm going to go live again tonight, so we can celebrate the crash course, the chemistry crash course, starting tomorrow. And maybe tonight I can finish this off. I'll do a little vote in the beginning of the live, and ask you guys if you'd rather do bio, if you'd rather do chem. It's going to be, let me check. It's going to be, let me tell you the actual time, because actually I have my schedule right now. It's going to be at like 6:30 CST. I'm going to put that down here. 6:30 CST. We're going to do another session. Okay, do you guys want to do chemistry? It's going to be 6:30 CST. We're going to either finish this one, not UK time. So it's 5:30 UK time if you want to do UK time as well. So CST is 6:30 and then 5:30 UK time. Chem. Someone said they failed their chemistry 3 times. Fingers crossed this year. Let's do bio. Okay, I'm going to do a vote in the beginning, and I'm going to ask people, okay, which topic they want to do, and then we'll do that in the beginning. If not, we're going to continue off with the rest of this question. But remember, please do join the crash course. It starts tomorrow. You can even join later. There's no rush to join it today. Maybe you're feeling iffy about purchasing. That's completely normal. But if you really want to join it live, try to join by tomorrow. The discount code, remember, is